Okay, Rose, second set of problems involves synthetic division, which is almost the same thing as synthetic substitution. So on page 334, I'm going to look at the class exercise number 7, which says take 2x to the third minus 3x squared plus 2x minus 4 and divide all that by x minus 2. So I start with what I divide by. If I'm dividing by x minus 2, I put positive 2 in a box. You take the number that would zero out the divisor. I guess that's the best way I can do it. So if you're dividing by x minus 2, you put 2 in a box. And then to the right of that, you take the coefficients of the polynomial you're dividing. So since it's 2x cubed minus 3x squared plus 2x minus 4, I just take the numbers in front of the x's. So I would write out 2, negative 3, 2, negative 4, and again, leave myself a little space below those numbers and draw a straight line. And then I do the same algorithm I went through with the synthetic substitution. I bring 2 down below the line, write it down there, and then my multiplier is also a 2. So 2 times 2 is 4. That moves diagonally up and to the right. So now my second column, so to speak, has a negative 3 and a 4. When I add those up, I get positive 1. That goes below the line. Then I keep using that multiplier, which is 2. 2 times 1 is 2. That moves up and to the right. It's in the third column. So the third column has a 2 and a 2. When I add those up, I get 4, which goes below the line. Finally, 2 times 4 is 8. That moves into the fourth column beneath negative 4. So the fourth column has a negative 4 and an 8, which adds up to 4. I circle that because that's the last number I have. That's actually my remainder. So the answer is when you divide those polynomials, I'm left below the line. I have the numbers 2, 1, 4, and then I have a 4 circled. That's my remainder. The 2, 1, 4 represents, and I'd write this out, 2x squared plus 1x plus 4 with a remainder of 4. Okay, 2x squared plus x plus 4, remainder 4. That can also be expressed as 2x squared plus x plus 4 plus 4 divided by x minus 2. So whatever your remainder is, it gets divided by whatever you divided by. I know, sounds pretty glunky. Feel free to rewind if I'm confusing you at all. If you'd like to feel through an example, a good example would be example 3 on page 332. Kind of the bottom of 332, example 3 would be a good example to feel your way through. All right, I'm going to do one more example. It's a division problem. We're going to take x to the 5th minus 5x squared and divide by x plus 3. Now I'm dividing by x plus 3. That means my multiplier, or the number in the box, is negative 3. And then you got to watch x to the 5th minus 5x squared is missing a bunch of terms. So everywhere I'm missing a term, I have to put a 0 in my string of numbers. I'm going to work left to right here. So I got negative 3 in a box. X to the 5th, I would just write 1 because it's 1x to the 5th. I don't have an x to the 4th or an x to the 3rd, so I write 0. So far I have 1, 0, 0. And then I have a negative 5x squared, so I'd write negative 5. And then I need 2 more zeros after the negative 5 because I don't have an x term and I don't have a constant term. So across the top here, I have negative 3 in a box. Then I have 1, 0, 0, negative 5, 0, 0. Beneath that, I'm leaving blank for now, and then I have a line drawn. And then I do this synthetic division. Right, I bring down 1. Oh, don't mind that. That's my cats having a fight. Stop it, guys. Bring down 1. That goes to the line. Then I use my multiplier. Negative 3 times 1 is negative 3. That goes beneath my first 0. If I add 0 and -3, I get -3. That goes below the line. My multiplier is -3. When I multiply that by the -3 beneath the line, I get 9, which goes underneath my second 0. Add down. 0 plus 9 is 9. That goes below the line. Use the multiplier -3. -3 times 9 is -27. That goes just beneath -5. If I add down, -5 minus 27 is -32. -3 times -32 is positive 96. Add down, that goes beneath the 0. So 0 plus 96 is 96. That's beneath the line. Last multiplication, -3 times 96 is -288. That's in the last column beneath the 0, and 0, if you add a -288, is -288. That gets circled because that's my remainder. And we started with x to the 5th, so my polynomial after division will be an x to the 4th. My numbers beneath the line are 1, -3, 9, -32, 96, and I have a -288 circled. So the 1 is really a 1x to the 4th, minus 3x to the 3rd, plus 9x to the 2nd, minus 32x plus 96. Remainder, for remainder, I just put a capital R, and then I put a minus 288. And the other way, there's an alternative way to express this. I could do x, the beginning stays the same, x to the 4th, minus 3x cubed plus 9x squared, minus 32x plus 96, minus 288 over x plus 3. Okay, hope you're able to understand all that.